In this video, we're going to cover partial fractions. What is a partial fraction? Why do you even use them? When do you use them? And so on. We use the method of partial fractions when we're trying to integrate a fraction or try to simplify it. Like when you were solving a differential equation, maybe using Laplace transforms or something like that. So usually you have a large fraction and you break it up as a sum of smaller fractions. And that's what the idea of partial fractions is. In order to do this, first we need to factor the denominator. So we have a long denominator and we factor it. Let's suppose we have a fraction like this. When you factor the denominator, it'll be the product of A, B, and C. So A, B, C are factors. So what you do is you break up this big fraction here into smaller fractions. One with the denominator A, one with the denominator B, and one with the denominator C in general. And what's going to go in the numerator, we have to calculate. It's not going to be D. It's going to be different expressions or numbers, D1, D2, and D3. For example, how do you pick D1, D2, and D3? How do you find them? Here's an example. Suppose we have this fraction here, x minus 2 divided by, I'm going to give a factored form of the denominator, x minus 3, x minus 5. So to break this fraction up, we're going to do this. We're going to write the first denominator here and the second denominator here. So we broke this fraction as a sum of two fractions, one with the denominator x minus 3 and one with the denominator x minus 5. Okay, if the denominator is linear, then the numerator will be a number like A. So here it will be A. The denominator is linear, the number here will be B. And then we need to find A and B. We'll do some examples that cover all the details in a little bit. Okay. We have another fraction like this. Let's say here we have x squared plus 4. And here we have x minus 1. And then the numerator can be anything. It can be a number. It can be x minus 2. Let's put a number like 6. So when you break this up, you break it up like this. The first denominator is x squared plus 4. Second denominator is x minus 1. Okay. We'll start with the second denominator. The second denominator is linear, so the numerator will be a constant. First denominator is a quadratic, so the numerator will be ax plus b. Linear. And then we need to find A, B, and C, put them back here. Make sure when you have a quadratic or higher, make sure that it cannot be factored any further. Because if it can, this was a quadratic before. This was x squared minus 8x plus 15. I'll write it down. And when you factor it, you get x minus 3 times x minus 5. So make sure this is not factorable before you do this. Let's look at this example. 3 over x squared plus 6x plus 8. Well, first we need to factor the denominator if possible. The denominator can be factored as x plus 2, x plus 4. The numerator stays as 3. Now we need to break this up as a fraction with the denominator x plus 2 and a fraction with the denominator of x plus 4. I'm going to put a plus between them, but you can put any sign you want. And then when you find the numbers here, you can change the sign. So let's call this constant here a and this b, because this is linear. This will be a constant. So if somebody puts negative b, make sure you stick to it in the end. Okay, now we need to rebuild this. So 3 over x plus 2, x plus 4 equals. Let's rebuild this fraction. So this will be the least common denominator here is x plus 2 times x plus 4. A times x plus 4 plus b times x plus 2. We want these two quantities to be equal for all values of x. The denominators are already equal, so therefore the numerator 3 must equal a times x plus 4 plus b times x plus 2. Let's call this equation 1. Okay, there are several ways to solve equation 1. We're looking for a and b. In the first method, method 1, what we do is we expand this and then we factor out an x. So we'll end up with 3 equals ax plus 4a plus bx plus 2b. Group the terms that have x in them. So a plus b times x plus 4a plus 2b. Okay, I'm going to rewrite the left side. The left side is 0x plus 3. 0x plus 3. The coefficient of x on the right side is a plus b. The coefficient of x on the left side is 0. So a plus b must equal 0. The constant coefficient on the right side is 4a plus 2b. And then the constant coefficient on the left side is 3. So we match these coefficients. So a plus b must equal 0. I'll underline it. A plus b must equal 0. And 4a plus 2b must equal 3. And now we need to solve a system of two equations in two unknowns. Okay, let's solve the first equation. First equation is take a to the right side, so that gives you b equals minus 2a. So where you see a b in the second equation, 4a plus 2b, it's plus 2 times negative a equals 3. 4a minus 2a is 2a. 2a equals 3, so a equals 3 halves. You found a equals 3 halves, b is minus a, so b must equal minus 3 halves. So therefore, the partial fractions for this example here, the partial fractions breakdown is going to be a over x plus 2 plus b over x plus 4. So it'll be 3 halves over x plus 2 minus 3 halves over x plus 4. And this is the breakdown of this fraction here. So if we need to integrate it or do anything to it, this is what we use. This is like a simplification. Now we're going to go over the second method. So let's go back to equation 1. Here's equation 1 and take it from there. I rewrote equation 1 here. Here's equation 1 and it's method 2. In method 2, we know that this has to be true for all values of x. So we pick as many values of x that we want, or as many values of x as we have unknowns. We have two unknowns, so we pick two numbers for x. Okay, you can pick x equals 99 and x equals 147, but that's just going to make things complicated. I would rather pick x equals negative 4. So let x equals negative 4, simplify this equation. And after that, I'll pick x equals negative 2, simplify it. I'll get my unknowns. If I pick x equals minus 4, I'll end up with 3 equals minus 4 plus 4 is 0, so this whole term goes away. b times negative 4 plus 2. And this will give us b. So 3 equals negative 2b. That means b equals minus 3 halves. Good. Let us pick x equals negative 2. X equals minus 2. Look at the second term. Minus 2 plus 2 is 0. So that leaves me with 3 equals a times minus 2 plus 4. So that gives me a equals 3 halves. And that's the two unknowns. And this is method 2. Okay. What if when you factor the denominator, you end up with something like this? Like x minus 3 squared. And then you have something in the numerator. Let's just call it n. It can have x in it or not, doesn't matter. When you break it up, okay, x minus 3 squared is x minus 3 times x minus 3. But, okay, I wrote this. But when you break it up, this is how you break it up. It'll be x minus 3. The second term will not be x minus 3. Will not have x minus 3 in the denominator. It will be x minus 3 squared. And the numerator is still a constant here and a constant here. And if you have 3 of them, like n over ax plus b cubed. Then you break this up as ax plus b plus ax plus b squared plus ax plus b cubed. And since this is linear, the numerator will be some number. So I'm going to call it, let's call it C1. Let's call this one C2 and C3. They don't have to be the same. So you just break this up 3 times, but one with the power exponent 1, one with the power of 2, and one with the power of 3.